So question 8. A 420 nanometer light is used in a photoelectric effect. So we have photoelectric effect. So we use a light with wavelength 420 nanometer. Okay, so figure 8.1 show the graph of maximum kinetic energy against the frequency for above experiments. Determine the stopping potential. So we want to find V as the stopping potential for these photoelectric effect experiments. So we are given graph Kmax against frequency. So if we refer to the graph given, we understood the x-intercept. The x-intercept of graph Kmax against frequency is referred to the tracer frequency. The tracer frequency for the photoelectric effect. So the tracer frequency will be 6.54 to the power of 14 Hertz. So we want to relate with the stopping potential. We want to find stopping potential. So if we refer to the list of formula given, so we might use equation 81. We might use equation 81 because we can get the tracer frequency from the graph. So by referring to equation 81, so VEVS will equal to HF minus HF naught. So the HF here is referred to the energy of the lights we use. So this HF can relate with the wavelengths, whereby HF is Hc over lambda. If you refer equation 80, so HF actually is equal to Hc over lambda. So I put into the equation H. So frequency is C over lambda. So Hc over lambda minus HF naught. So then I can put in all the value. So E is referred to the elementary charge. So you can refer the value from the list of constant value. So stopping potential we want to determine. Planck constant, refer list of constant. And same go for C, speed of light, refer to the list of constant. Divide by the wavelength of the light we use, 420 nanometer times 10 negative 9 minus again Planck constant. So multiplied with the threshold frequency read from the intercept of the graph, 6.54 to the power of 14. So we will get our stopping potential. So if you do your calculations correctly, you should get your stopping potential will be around 0.25 volts. So then we move on to question B. We are given figure 8.2a and 8.2b, which show the graph of stopping potential against frequency and current against voltage for photoelectric effects experiments P and Q. So if we refer to the graph stopping potential against frequency, we know that the x-intercept will represent the tracer frequency for experiment P and also the tracer frequency for experiment Q. And then for the second graph, current against voltage, so we know that the intercept x here will represent the stopping potential. So for experiment Q and also stopping potential for experiment P. So what have been changed in the experiment P if we compare to experiment Q? So the type of matter or the target matter have been changed in experiment P if we compare to experiment Q. Why? Because if we refer to equations 83, EVS is HF minus W naught, whereby if you refer equation 82, the W naught is equal to HF naught. So as HF constant, if the energy of the incoming photon is constant, the smaller value of word functions will give the greater value of stopping potential. Okay, so if we compare experiment P to experiment Q, the thing that have been changed in the experiment is the type of matter.